Hi, I'm TechneMoira and welcome to my channel. Today we're going to investigate a Technics SL-PG480A CD player. So grab something to eat or to drink, sit back in your favorite seat and enjoy. I got this CD player not too long ago on eBay, and as far as I can remember, the description said that it isn't functioning. So it's a Technics CD player, Technics SL-PG480A, and cosmetically it looks okay. I mean, there are the usual scratches and dings here and there on its front and on the top of the case. Alright, so I would say cosmetically it's okay. I think the scratches can be removed somewhat with some very light polishing and cleaning, but yeah, I think all in all the state of it looks okay. Alright, 5 screws later, the top of the case should come off. There you go. Okay, let me show you what's inside, So on this side, well, the very first thing we notice when we take a look at the whole case is that there's precious little inside the case. I mean, it's a huge case, but it's only filled for 2/3, or maybe half of it is only filled with one main board here, and then obviously the CD player here. And if you rotate the whole thing a little bit, then you can tell there is a board attached to the front of the CD player, right? So the board nearly covers the entirety of the front panel of the CD player. Certain parts of the power supply are really easily recognizable, right? So here you have the transformer, and then you have 4 diodes mounted in what I would call a classic bridge rectifier position. And then there are a number of caps, filter caps. There's a power transistor here, or a power regulator perhaps right here. And then the rest of the board, I don't know yet, but I would guess is intended to create voltages to power the CD player. Alright, so the whole power section here powers the front panel, I'm guessing through this connector right here, and then the CD player through this connector here, right, which is nothing more than a flat cable mounted in an edge connector Okay. Now, as far as I can remember, the seller told me that the CD player is not doing anything. It doesn't react, it doesn't seem to work. It's tempting though to connect the CD player up to the AC power and just see what happens when you switch it on. But I would say, you know, if you want to avoid damaging more the CD player in this case, then I would advise to, let's say, refrain from giving in to the impulse of wanting to connect it up to the AC and just switch it on to see what happens. To release the main board from the chassis of the CD player, there are a number of screws you need to unscrew, and to start with the screws at the back. Yeah, there are two screws which are holding in the connectors, the audio connectors and the AC power connector, right? And these are directly soldered onto the main board. So you need to release those first, which is exactly what I'm going to do. To me it looks rather virgin territory. I don't see any obvious signs of tampering with the main board. So I think, yeah, maybe people have opened up the CD player, but they haven't worked on the main board yet. Okay, the next thing I need to undo is the transformer, which is 3 screws. 1, 2, 3. Okay, so 3 rather long screws like these. Okay, let me show you from a close-up. Yeah, so 3 screws like this. When I open up and unmount some device, I always go from the top to the bottom and from the left to the right. That way, when I need to put back together everything when I'm done, I just need to reverse the order to find the necessary screws. And now there's one screw here. Okay, a long blackish screw. I'm guessing this used to be brass colored, but it looks rather dark colored now. So the main board should be loose now. So what I need to do now is to disconnect 3 connectors. So there's an edge connector here, which is connected to the CD player itself. Yeah, as you can tell, it runs directly to the mechanism of the CD player. Then there is another edge connector, well, not an edge connector, a simple straight connector, which seems to run to the front panel. And then there's another connector here, which seems to be like a bus, so where the main board plugs into the front panel PCB. Unfortunately, I noticed now that I will probably have to unmount the back of the CD player to take out the main board, because I need to pull it back. Alright, I made an inventory of all the electrolytics that I would need to replace the capacitors on the main board of the Technics CD player, right? And there are 11 capacitors in total. So 47 at 6.3 volts, 3 pieces, 330 microfarad at 25 volts, 2 pieces, 100 microfarad at 25 volts, 3 pieces, 2200 microfarad 16 volt 1 piece, and then 2 100 microfarad 50 volts capacitors. So, but that's for the main board. I haven't taken a closer look at the front panel board yet. Maybe I need to replace a few caps there, and who knows, maybe even in the CD player itself, right? But let's start by replacing the electrolytics on the main board, because there aren't that many to replace, and then we'll take it from there. Alright, I'm I'm still looking for a potential fault on the power board, and you could say slowly but surely I'm circling around the possible error or fault areas, and right now my attention has been drawn to this little transistor you see right here. Let me give you a close-up. So, right, where are you? Right there. Come on, focus, focus, focus. Right there. So Q12 right here is acting a little bit strange. Yeah. I was measuring the voltages over the whole board according to the schematic, and when I came to Q12, which seems to be a little bit like a linchpin of the whole circuit, I found that there was something strange going on. So if you look on the schematic, and you look at the voltages around Q12, you will notice that they say the voltage around the emitter of Q12 should be, let's say, around 12.7 to 12.9 volts positive, right? Now, when I measure the voltage around, well, at the emitter of Q12, which is exactly here, okay, then I'm getting this voltage over there, 14.3 volts. Okay, so that's the voltage I'm getting, 14.2, 14.3, and that's no good. Yeah, I'm over like, let's see, 12, if we take 12.7 or 12.9, let's say, then I'm almost a volt and a half over the recommended voltage. This transistor here is not entirely kosher. Alright, the plot thickens like a bad 1940s detective movie, And I'm still measuring all the voltages according to the schematic of the main board of the CD player, and by going through the schematic systematically, I may have found a new suspect. So just as a reminder, when I measure the voltage around Q16, so this transistor here, the collector voltage here is not minus, say, 41.2 or minus 40.4 or any voltage between them, but it's over 52 volts negative, which is really way too much, way too much. So I started following the circuit downstream, and I ended up in the part here with transistor Q15, yeah, right here. And I started measuring the voltages around this transistor here, Q15, and you'll notice that if I do, so I'll measure the voltages around the emitter first and then around the collector. Okay, so first the emitter of Q15 is right down here. I don't know if you guys can see this, but right, that little transistor here, can you see this right here? Yeah, I'm still measuring voltages on the main board of the CD player, and you know, because I'm still trying to solve the problem which I measured on the main board following the schematic, right? So whenever I measure the voltage at the collector of transistor Q16, instead of finding minus 41.2 volts or minus 40.4 volts or something in between, I don't know if you guys can see that, but let me give you a close-up. So alright, so I never find any voltage around these values here. Rather, I find a value of around minus 52 or sometimes even minus 53 volts at the collector. So nothing close to these voltages here. So I started following the schematic downstream and measuring voltages as I went along, and of course the plot thickened like a bad 1940s detective movie, and yeah, I slowly but surely found voltages that were off, you know, that weren't really according to what the schematic says they should be. And I finally arrived now at transistor Q15. So you can see here the voltages of the emitter should be, at the emitter should be 9.2 volts, and at the collector 9 volts, right? So, and then the base, let's say, should be 8.4. Alright, so now let's take a look at Q15. So Q15 is right there. So I'm going to show you where it is now. Okay, so this is Q15. Alright, so we're going to measure the voltages in a minute at the emitter, the collector, and then the base. Remember, according to the schematic, yeah, the voltage at Q, the emitter of Q15, should be around 9.2 volts. Alright, so let's measure that, Q15 emitter. And I'm measuring 9.39 volts. Alright, so that's what I'm measuring at the emitter. So it's a bit too high. It's let's say I would say 200 millivolts too high, something like that, 180. Okay, so now the voltage at the collector should be 9 volts, which is the center pin on the transistor. Okay, and that's 9.32. Alright, 9.31. Okay, and remember, it should be around 9 volts, right? Okay, so now I move to the base of Q15. Yeah, and now I measure 8.64 volts. Yeah, and I should measure around 8.4 volts. So it's not correct. Okay, so these voltages are not right. Alright, I decided to take a break from debugging the main board of the CD player, which is over here. There are still a few quote-unquote mysteries that I need to solve somehow of the board. But like I said, I decided to take a break of this PCB, and now I'm going to concentrate a bit more on the main front panel of the CD player and the CD reader itself, you know, the mechanism. So for convenience, for reasons of convenience, I'm going to disassemble the whole thing, you know, because it's just much easier for me to be able to work on it when it's completely disassembled. So that involves unscrewing and unclipping a few PCBs which are attached to the front panel. So the PCB you see here with the main processor of the CD player, and then a few smaller PCBs which are more involved with switching the CD player. Alright, so yeah, give me a moment to do just that, and when I'm done I'll give you an overview of what I unmounted. Alright, step 1, unmounting the CD player mechanism itself from the chassis of the CD player is really very simple. It involves unscrewing exactly 4 screws from the top of the player itself. You know, you can see the holes down there where the screws are located. So I don't remember exactly which one yeah, okay, this hole here, and the one on the other side, and then that hole over there, the lower one, okay, and exactly the same one on the other side. So yeah, unmounting the CD player itself is really child's play. So yeah, that's done. And then the front panel is really not much more difficult to unmount from the chassis. It just takes removing 3 screws from the lower, or well, yes, the lower lip of the front panel. Alright, which I did, and here is the front panel mount. Now I suspect there are a few electrolytics on the other side of this board, so I think maybe it would be interesting to have a look at the top side of the PCB, and that involves unscrewing 1, 2, 3, 4, 5, 6, 7, 8, 9 screws. So yeah, let's do just that, and let's see how the front panel PCB looks like topside. Alright, I unmounted the power switch assembly from the front panel bezel, and the first thing you notice is these little membrane switches here, which in my opinion are a bit cheapo, but I guess if they are okay, they work just fine. So the next thing I notice is one electrolytic, one tiny electrolytic right here that I need to, well, that I want to replace. And then the next thing you notice is this, which I suspect is an infrared sensor right here. Okay, so, and if I'm not mistaken, that is actually a transistor. There. So it's possible that it's more like an integrated infrared circuit rather than a transistor. And as you can see or tell on the PCB, it has a signal pin, a ground, and a plus 5 volts pin. So yeah, it's, strictly speaking, it's not a transistor, although it has 3 pins. The electrolytic below it needs also, well, I want to replace that one too. The little capacitor you see right here is a 47 microfarad, 6.3 volts, but I guess a capacitor of slightly higher voltage will do, as long as its size doesn't exceed by too much the size of this one, right? Okay, and then finally, what you notice on the board, on top side on the PCB, is the VFD display. Okay, and that one looks okay. I mean, at first glance, I don't see any damage to it. I don't think it's leaky, because the flashing you see right here, yeah, but I'm calling it flashing right now because for a second here I can't remember the exact term for this spot, but let's say it's some deposited metal compound which is on the inside of the tube and absorbs any air or gas molecules, you know, which remain after pulling the tube vacuum. Yeah, there's always a little bit of gas left behind, and this metal compound, this flashed metal compound, makes sure that the few gas molecules which are inside the tube are absorbed, so that the gas would not interfere with the working of the tube, right? And it's still there, and it looks metallic, you know, and it looks okay. So yeah, I don't think the VFD tube is faulty. Of course, it's quite possible that this tube, of course, has filaments too. You could say like an old light bulb, right? If the filaments are, for whatever reason, broken, then yes, then the tube might not work at all. Alright, so here's the little capacitor that I extracted, and it's slightly higher in value. It's almost 51 microfarad, but look at that, it's 4.4% lossy, so which is, well, pretty lossy, electrically lossy, and it has an ESR of 2.1, although an ESR of that kind for those tiny little caps, I've noticed, is rather normal, I would say. I mean, sure, it doesn't feel normal, but it really, those tiny little caps apparently have a higher ESR than bigger caps. Yeah. Don't ask me why. I'm not a capacitor engineer, so I couldn't tell you why exactly the ESR is higher for little capacitors, although I have a few hypotheses why that is. But I'll talk about that sort of thing in another video. Alright, I cleaned and replaced the cap on the front panel PCB. Now I'm going to focus on the CD player, and I put the CD player on its head, so this is top side. Let me show you. So this is the top side of the CD player, and this is the underside. Alright, I just want to have a look at the underside to see whether everything looks normal, and for that I need to unscrew this PCB, and that's held in with 3 screws. So let me see. 1, 3 Phillips screws, by the way. 2, 3. Alright, so let's lift it carefully. Okay. Alright. Ooh. Alright, there are quite a few electrolytics on that board. So methinks that I should probably replace those as well. Alright, so below the main board of the CD player, if you lift it carefully, this is what you see on the inside. And the first things one would probably notice, being under here, is the CD player has actually 3 motors. Wow, that's yeah, that's rare. I mean, most modern CD players often have only just 1 motor, but no, this one has 3. So can you see the third one? It's right here. Right here, below this little PCB here. And then you have the CD playing motor right here. So this spins the CDs, and that little one over there, I think, moves the reading head along the CD player. Okay. The weird thing is, though, that it's just a simple brushed DC motor. Yeah, it's not even a stepping motor, it's a simple DC motor. Okay, that's peculiar, but okay. Maybe it is accurate enough. So anyway, yeah, I've got 3 motors that I need to clean and grease, more than likely. And then there's the mount here for the laser. And the laser being on the top side right now, which is facing downward. Okay, so like I said, I'm going to disconnect the main PCB of the CD player, and then I'm going to more than likely replace all the electrolytics which are on the board. Alright, I'm getting ready to go to bed, but before I do, I just wanted to say that I replaced all the capacitors on the driver board of the CD player. So I mean all the electrolytics were replaced. And by the way, an interesting little detail, this oval blue part right there, yeah, is a crystal. Alright, so let me show you from the other side. There. This crystal is rated for 16.93 megahertz. At least that's how I interpret it. Okay. So yeah, that oblong blue little bean like component is actually a crystal. But you know, to me it looks a bit cheapo, but well, okay, that's what it is. By the way, there is a similar crystal on the front panel of the CD player, right over there, in fact, and that one is rated at 4.23 megahertz. Okay, I'm not 100% sure, but that's how I read it anyhow. So yeah, that's a crystal. So apparently the processor of the CD player runs at 4.23 megahertz. Okay, and the controller for the CD player itself, yeah, runs apparently at 16 megahertz or thereabouts. Yeah, 16.93 megahertz. So yeah, interesting little detail. Anyway, what I'm going to do before I shut down the lab for the night is I'm going to soak all the moving mechanical parts, and more specifically the gears and such, the worm gear you see down there, the gear, the motors. I'm going to soak them, well, I'm going to give them a little bit of a spray of WD-40, okay, and we'll let it soak overnight, and hopefully the WD-40 will release most of the dried up, caked old grease from the gears, and that way we'll be able to put some fresh lithium grease on them. Alright, back to the main board of the Technics CD player. So I did some research and some deep soul searching and did a lot of thinking. I have to admit, nowadays I need quite a bit more time to think problems through. But either way, be that as it may, I came to the conclusion that the voltages that I measured at Q12, which is the top transistor here, and at the emitter, was really way too high. You'll remember that I measured voltages like 14.6 and 14.8 and such like that, which is really way too high. And here at Q13 at the emitter, I measured like minus 13.4 and things like that. So the voltages were really off. So too far from what the values really should be, right? So I did some, like I said, I did some thinking, and I came to the conclusion that the biasing of this transistor here was off. For some reason it was off. Now you could reason, of course, that the engineers at Technics had it all figured out, and I don't doubt they are very intelligent people, but I think there's something a little bit more sneaky going on. I think that there was perhaps a little bit of planned obsolescence going on. So in other words, this power regulating circuit gave out a bit more voltage, not crazy more voltage, but still a bit more voltage than is probably necessary, which downstream would wear down a few parts, right? So, and I figured out that in the end the biasing of this transistor here, Q12, was a bit, how shall I call it, a bit too hard. Okay, so the transistor was letting through too much voltage. So I reasoned that I needed to bring down the biasing on its base. Yeah, and I did that after some calculating with a 5.6 kilo ohm resistor, which bridges C19. So from that point here to ground. Alright, and now the voltages all seem to be okay. Let me show you. So I've got the voltmeter hooked up to well, the ground of the voltmeter I've got hooked up to the ground of the main board. And now let me show you what the voltages are, so, or rather what the voltage is at the emitter of Q12. Okay, so here we go. .77, so pretty close to, let's say, 12.8. And if you look at the schematic, the voltage they want at the emitter of Q12 is between, let's say, 12.7 and 12.9. So 12.77 is more than good enough, right? So let me show you how I did that on the back side of the main board. Alright, so I quickly disconnected the main board from the AC. So as you can tell, I tacked in a 5.6 kilo ohm resistor between bridging, in essence, C19. Alright, so the contacts you see over here are the ones of C19. And that brought the biasing of Q12 down to the exactly wanted level. Well, I say exactly, let's say very, very close to the level that you want the biasing to be. And conversely, of course, if you look at it from the schematic point of view, conversely, bringing down the biasing of Q12 also influences, of course, the biasing eventually of Q13, right? So by tacking a resistor right there at this point precisely, brought down all the voltages to a very normal level. So what's going on here? Is this a design error? Is this something that was willfully done somewhere in the past? I don't know. Maybe the schematic is wrong. Although I doubt it. I mean, the board is identical to the schematic as far as I can tell. So yeah, there's something weird going on. Now, either way, whatever the reason was for biasing the transistor the way it was biased, it's now solved by tacking in that 5.6 kilo ohm parallel, you could say, with C19. And just like that, this is the fix on the main board. And so I tacked one end of the 5.6 kilo ohm resistor, which by the way is a 1/4 watt resistor. I fixed one end to this point here, which conveniently was not used on the board. Alright, and that point goes to, I'll tell you where it goes to the negative end of the capacitor C19, so right here. Alright, so that goes to that, and then the positive end of C19, which is the lower contact here, goes all the way down to this point here where my thumb is. Yeah, this is R12, and this point here is the other end of C19. Alright, so when you go back to the top side of the main board, you can see that now R12 and the 5.6 kilo ohm resistor share the same contact point down there. Alright, so there you go. That's the fix I mounted. I also noted on the main PCB the value of the resistor for should anyone at a later date want to service this board. Then at least they won't have to look around for what sort of value it was or is, and that will possibly make their lives a little bit simpler and easier. Okay, so there you go, that's the fix that I did. I suppose some of you will find it rather unorthodox as a solution, but hey, you know, errors are always possible, and it's not that unusual that a tech needs to sort of, you could say, adapt an existing circuit to function a little bit better, and that's exactly what I did. You know, in fact, the board now functions pretty close to what the schematic says it should deliver, right? So it is effectively a fix. So yeah, think of it as a revision of the power supply of the Technics CD player. Alright, I brought back a few CDs of music that I like to listen to. First, I have CD of the Talking Heads, a band of the 80s I was particularly fond of when I was a teenager. Good music, basically, the Talking Heads. And then something I bought much later, which is music from Michael Nyman of the movie The Draughtsman Contract. Very good movie. You could say it's a dagger and cloak movie, but conceived a little bit like a detective movie, and it's all happening in the 18th century, right? So it's a little bit romantic as well, mysterious as well. So yeah, not a bad movie. The Draughtsman Contract, and the music of Michael Nyman is special but pleasant to listen to in the background. Anyway, let's see if the CD player will recognize the Talking Head CD. Okay, here goes. Alright. There are 8 songs on the CD, so let's see if it finds any, right? Okay, here it goes. Oh, it says no disc. And the disc is not rotating. Aha. Well, that is not good. Okay. Okay, so that is not good. That means that I still have some work to do. So yes, it would seem that it would seem that the CD player is not working properly. I can hear the head move back and forth trying to read the CD, but since the CD is not running, yeah, there's, of course it won't discover a disc, let's say. So yes, there's a problem with the mechanism, so let's have a closer look at it. Before I switch off the thing, let's see if I can activate any other menu on the player. Boom, boom, boom. Could I activate something here? Let's say time mode. No. Well, in all likelihood, since there's no disk in it, I won't be able to access any of the menus, I'm afraid. Okay, so I need to have a closer look at the mechanism of the CD player itself and see whether there's something I can do to repair it, right? Well, I think this will be it so far. The video is threatening to become a bit too long, and anyway, I'm still diagnosing what could be wrong with the CD player mechanism. I have a feeling I'm pretty close to finding out what the problem could be, but I've ordered a few parts, and until then there's really not very much I can do, except maybe cleaning the case a bit. So yeah, I'm sorry guys, you'll have to exert a little bit of patience until I receive the parts I ordered and I can do some more practical diagnosing and hopefully repairing of the CD player. So that will be it so far. I hope you enjoyed it, and thank you for watching the video, and I'll see you soon for episode 2 in repairing the Technics CD player. Thanks for watching and see you soon.